Assalamualaikum Inhal. Nama is SITI Amran. Number is F18A0375. My supervisor is Dr. Hassan Aaron. Today I want to present about my final year project proposal, which is determination of optimal inclusion rate of pre-treated SFL with calcium salt as a feed for microbiome reserving juvenile. My final year project is about producing pellet for microbiome reserving juvenile using SFL that was made with basil salt. As we know, microbiome reserving is economically important because it grows faster among the freshwater plant, according to Mukopadhyay in 2003. In Malaysia, the production of microbiome reserving was recorded in 1917 according to the FAO data. The most costly part in aquaculture management is the feed. The estimated feed cost is about 30 into 27% of the total annual cost of the production. However, the feed is one of the biggest sources of the nutrient to the animals and aquaculture species. One of the most important requirements is protein. The protein becomes the most important in the dietary requirement because it influences the formulation of the growth of the animal. The most costly ingredient in the making of pellet is the protein source. But now, BSFL are widely used as a protein source is animal feed because the cost of BSFL is cheaper compared to other protein source. Therefore, I will do a research on the effectiveness of BSFL to microbiome resemble juvenile. The main problem that had been facing by most of the farmers is the cost production of the feed. The use of fish meal, shrimp meal, soybean meal and others are a bit costly. The source of protein is important in microbiome reservoir growth to produce a good quality of juvenile microbiome reservoir. The use of BSFL are not commercially used as a protein source because of its high rich protein source and cheap compared to other protein source. Significance of study for my project is feed formulation using BSFL benefits in terms of growth and quality to microbiome resemble ruminant. From this study, data on its nutrient composition and potential application in the feed industry will be revealed. Finding from this study will eventually lower the cost for feed production, thus benefiting the farmers by providing cheap, safe and environmental friendly feed. The main objective of the present study is to determine potential application of the SFL as feed ingredient to partially replace protein requirement for microbiome reservoir juvenile. The specific objectives are as follows: to determine the optimal feed formulation using BSFL that meet nutrient requirement for microbiome reservoir juvenile, and to investigate the effects of newly formulated feed on the growth and survivability of microbiome reservoir juvenile. For null hypothesis, different inclusion levels of BSFL has no significant difference between effect on the feed quality, growth and survivability of microbiome reservoir juvenile, while for H1, different inclusion level of BSFL has significant difference between effect on the feed quality, growth and survivability of microbiome reservoir juvenile. The first one is general description of microbiome reservoir. Nowadays, several countries actively cultivate the microbiome reservoir for food. Giant freshwater prawns, or known as microbiome reservoir, has been introduced into more than 40 country and become one of the most cultivated freshwater prawn in the world. Giant freshwater prawn is one of the biggest freshwater prawn in the world. Macroberturus sabrechi actually can grow up to 320 mm and weigh over 200 grams. Prawns can ingest commercial pellets when available, and that prawn utilize available vegetation regardless of the presence of the commercial pellet. The second subtopic in my literature review is the nutrient requirement for Macroberturus mersenbergi juvenile. The diet requirement for giant freshwater prawn has not been systemized. However, during the last decade, expertise on diet requirement has been experimentally conducted for practical application. Next is feeds for Macroberturus mersenbergi. Usually, Macroberturus mersenbergi will eat all types of food as long as from animal or plant source. Macroberturus mersenbergi often eat natural feed like zooplankton or oligochaete worms for nutrition, and formulated feed that contain complete nutrients that required by the Macroberturus mersenbergi. The fourth one is black soldier fly larva, or known as BSFL. The SFL, or Hermatia illusions, is a widespread fly from the Strathomyid family. Though originally native to the Americas, it now occurs worldwide in tropical and temperate regions. SFL can easily produce deep-rooting organic matter such as animal waste or decaying crops and from food waste. The last one is potential application of the SFL in feed formulation. SFL can be used as a protein source in animal feed because the SFL contains a high-rich protein. The SFL can be grown and harvested without dedicated facilities and are not pestiferous, and the larval growth period of more than 3 weeks is longer than that of fly lighthouse and carrion fly, implying that a single larva can eat more substrate and grow larger pupae. The first step for my final year project is sample preparation and processing. In this step, I will do the fatting process of black soldier fly larva and dry the powder of the defected BSFL, and then the fatted BSFL will be pre-treated with different percentage of basil salt. Then, I will formulate feed formulation using green feed and producing pellet that contains formulated BSFL with basil salt, fish meal, limestone, mineral premix, and vitamin. The next step is proximate analysis. In this step, I will do the analysis of crude protein, crude fat, crude fiber, moisture, and ash. I also will do physical characteristic tests on that formulated pellet. The test that I will run is sinking velocity, color analysis, and hydroability. The other test that I will run is texture profile analysis to test the hardness of the feed. Next, I will do feeding trial on Macroberturus mersenbergi for 8 weeks with 4 groups, that is control group, treatment 1, treatment 2, and treatment 3. The last one is statistic analysis using one-way ANOVA. At the end of the research project, it's expected that we can determine the optimal feed formulation using the SFL that meet nutrient requirement for Macroberturus mersenbergi juvenile. Other than that, it's expected that our target to investigate the effect of newly formulated feed on the growth and survivability of Macroberturus mersenbergi juvenile will be archived. This is my Gantt chart, and my project will be conducted in August. This is my milestone. This is my budget. for this project, my budget is about 132 ringgit for 3 kilogram of PSFL, 100 pieces of microbial severity juvenile, 1 box of gloves, 1 box of face mask, and 1 box of tissue. This is my reference that was used in this presentation. That's all from me. Thank you.